So now let's look at two more periodic trends. The first one is going to be ionization energy. Ionization energy. And the second one is electronegativity. These should be a little bit easier to remember because they actually have the exact same trend. And partly that has to do with the fact that they are similar in nature. They are looking at some similarities that you'll see in a minute. Ionization, that should tell you that it has to do with ions. So ionization is defined as how much energy, NRG is energy, just so you know, how much energy is required to remove one electron. So notice that we're removing an electron. If you remove an electron, you have created an ion, specifically a cation, because now it's positive. Electronegativity is how badly that element wants another electron. So what you'll notice about both of these trends is that as you go from left to right along the periodic table, they both increase. And as you go from top to bottom, they both decrease. And mostly for the same reasons, but we'll look at some differences in just a second. So when you're looking at ionization energy, you're looking at how difficult it is or how much energy is required to remove an electron. So let's look at lithium, which has 2 electrons in its first shell and 1 electron in its outer shell. This lithium atom is more than happy to just give away that final electron because once it gives it away, its outermost shell is full. It's going to be totally happy, right? So it is very, very willing to get rid of that electron, so that's very low energy. It does not require a lot of energy to get rid of that electron. On the other hand, if you go towards the right side of the periodic table, let's look at fluorine. Fluorine has its 2 electrons in its first shell. That's terrible. And then 7 in its outer shell. Fluorine really does not want to give away any of those outer electrons, really because it is so close to having a full shell. It really just wants to gain an electron. So the fact that it does not want to give up an electron means that it has very high ionization energy. It requires an enormous amount of energy to pull an electron off of that fluorine. Okay, now as you're going from top to bottom, the ionization energy decreases. This has to do with just how far away the electrons are from the center, from the positively charged nucleus. So let's look at rubidium. It's below lithium in the 5th energy level, or in the 5th period of the table. So it has, I'm going to draw all of these. It has 5, this is getting a little out of hand, it has 5 energy levels. That's rubidium. And I'm not going to draw all of the electrons, but you can kind of get an idea. Now remember, all the protons are here in the middle. They have a pretty strong pull on the electrons closest to them, but the further you get out, the harder it is to kind of keep them. So as you go down from lithium to rubidium and even farther, as you go from top to bottom on the periodic table, the amount of energy required decreases. So this is even lower energy required because those electrons are just not being held very tightly, so they can very easily be plucked off. So it does not take a lot of energy to pluck one of those electrons off. So keep in mind, from left to right it increases, and from top to bottom it decreases. This is also true for electronegativity. So electronegativity is how badly does that atom want another electron. We're going to look at lithium and fluorine again. So here's lithium with its 2 electrons here and its 1 right there. And here's fluorine, which has its 2 here and 7 in its outermost. Okay, so what I want you to think about is if we just said that lithium gets rid of that electron very, very easily, well then it also does not want another electron very badly. So since it has very low energy of ionization or low ionization energy, it also has low electronegativity. It has a very low desire for adding another electron. So low electronegativity. It really doesn't want to add another electron. Fluorine, on the other hand, really does want to add another electron. Remember, its ionization energy was very, very high because it would require a lot of energy to remove an electron. That's because its desire for another electron is very, very high. So high electronegativity because fluorine really wants that final electron to fulfill its octet rule. And then as you go from top to bottom, it decreases. So notice from left to right, electronegativity increases, and from top to bottom, it decreases. So let's look at rubidium again. 5 energy levels, 5 shells. Gets worse and worse every time I draw it. 5 shells. Now, remember that the protons inside the nucleus have a pull. They are trying to attract more electrons. However, since these electrons in this outermost shell are so far away, it doesn't have as strong of a pull. So it has even lower electronegativity because ultimately it just can't attract those electrons anymore because they're just so far away from the protons. So as you go from left to right, electronegativity increases, and as you go from top to bottom, it decreases. Okay, you need to be sure you understand the difference between these terms, ionization energy and electronegativity. We will look at electronegativity again when we start looking at bonding and ionic bonds in particular. But first and foremost, you need to understand these trends. Okay, so make sure that you realize ionization energy and electronegativity have the same trend, and the reasons are related to one another. However, they're a little bit different. So make sure that you are able to explain each of those. All right, that's all for periodic trends.